Hey, hi. Now we are going to solve this question. So, search in rotated sorted array 1. We have given the nums array okay like this. Then it is ascending order with distinct values. Okay, it is in the ascending order and distinct value and a target value k. Okay, this is the target value k which we have given. The array is rotated at some pivot point that is unknown. So, uh, unknown at unknown point which is rotated. Okay, let's say find index at which k is present, and if k is not present return -1. So here they are saying uh, rotated 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 at some pivot point. So they are saying that they have rotated the array at some pivot point which is unknown. Okay, then they have given us the k value which is 0, and we have to return index. Okay, index at where the k is present. So 0 1 2 3 4. Okay, then answer is here 4. So according to them what we have written, rotated in some pivot point means, suppose like this the array was like 0 1 2 4 5 6 and 7. Earlier it was the case, and after they have rotated it at some pivot point, like this is the point they have considered, and they rotated it like this and put it from here to directly here. So after it is now like this, 4 5 6 and 7, because on the fourth point they have rotated this array and put it on front. So like this the thing is changed for this array. After rotation we have k which is given to us which is 0, and we have to return the value of this 0. Like value means index of this 0th element where it is appearing. So if we do indexing of this array which is 0 1 2 3 4, here on the 4 it appears, so we return this fourth value. Okay, so brute solution I can think of is, simply we will traverse this whole array. After traversing this whole array we will find out that at some point this k value is equals to the value which is present at some point. This k value is equal to the value of the array of the array. Then at that position we return that particular index. So basically it's a simple linear traversal solution. So where the time complexity is big of n and we are not using extra space, so the space complexity over here is 1. So this is the solution of a brute force. So we will code it down real quick. So here we are in the uh, terminal. So we have to write the code for this. Let's do it. So we have given this array which is nums and the k value which is the target one. So first we'll determine the length of this array, nums dot length. Then we have to traverse on this particular array. Let's traverse on this particular array because it's a solution of a brute force which is a linear traversal. For and let I equals to 0, I is less than n, I plus plus over here. So after that at any point if you find your k value is exactly same as the value of the array, then just return that nums I, and if you did not find anything return -1 which is given over here, this one. So let's test it out. Let's see the answer. It's getting slow, my internet connection is a bit slow. So yeah, we get the answer. So it's a linear traversal, simple brute force solution. Now we will focus on the optimal solution, which which is binary binary search solution. How do I know it's binary search solution? Because we have given the ascending order, like the array is kind of sorted and we have to find some element in that array. Okay, the array is sorted and we have to find some element. Array sorted, need to find something, best way to binary search. But the problem is that after a rotation the array is not sorted over here. If array is not sorted over here, then I have to apply the binary search with some tweaks inside it. So binary search solution, binary search, first rule is what? First rule is sorted, and there must be a range, valid range. So I can think of a binary search, and let's do it. So this is the array we have given to us. So array over here, and this is the array. So if I can think of, like, okay, I need to do the binary search on it. So how can I do it? What is the sorted value? Okay, so at first what I'll do is, okay, I have this indexing for this array. So I know one thing, that the array must be sorted. So I'll do simply one thing. I'll find out the mid of these, this range. After finding the mid, suppose 0 to 6, this is the mid over here. On this it will be the, this is the mid over here, right? Or 3 is the mid. So I will think like, over here, if this is the mid, and if this is the mid, the low must be somewhere here and high must be somewhere here at last and first position. So I will have to find the k, which is 0. So I will first find out what is the sorted half, because I can apply the binary search on the sorted range. Okay, so sorted half is what? 4 7, is it sorted? I mean 4 7, is it sorted? Yes, it is sorted. What about the right half? 7 2, 7 is greater than 2, so this half is not sorted. So 4 is less than 7. Okay, this half is sorted. So I figured out, what I observed sorted half is the left one, which is this one. So after figuring out the sorted half like this, and I know on sorted half I can apply binary search. So now I have to apply the binary search. Know what I can do? Like, I will see my fourth value, I mean my kth value, like, which is 0. Does this lies in this range? If I do, I know k is given to me 0, and I'll see 4 is less than or equals to 0, or 0 is less than equals to 7. Does my k value lies in this sorted half of the range? Is it true? No, it is not true. No. So it means my left range, which I have uh, so this means my left range which I have, which is sorted, in that particular range my k value is not lied. So I have to trim down this left search space because it is not sorted. So doing the trimming of this left search space, I will simply move low one step ahead of mid. So after moving the low one step of a mid, what it will be, uh, low, now low will be here and high will be here. Okay, now just erase it, and low will be here and high will be here. Now this is the second iteration over here. So now low will be here, high will be here. Now I'll do simply again a binary search and find out the mid. The mid is basically 0, 4 and 6, which is 10, and mid is 5. So mid over here is 5. I'll again check this, which half is sorted. 4 6 5 6. Let's take this right one at first for the understanding. Does right half is sorted? Yes, it is sorted. Does in the right half I mean wait, right half is sorted, right? 1 and 2 is over here. Does in the right half that does in the right half my k value exist? So I'll check in the 1 2 0 0 less than 2. It does not exist, so I will eliminate this half. After eliminating this half, what will happen? After trimming down the right subspace, what will happen? High will come uh, just here. um, how do I write it over here? Okay, okay, after trimming the right search space, my high will point here. Okay, now this is gone. Now what will happen? I will see over here. Okay, now my 4, now this is my low and high, and over here I got the mid is equals to 4. Now I will first check, like, does my uh, value of this fourth index is equals to k? It will say yes. So yes, it is. Now I got the answer. So basically the key value and key pattern is that first identify identify the sorted half, then check does in that sorted part my k value exist or not. Simply on the basis of that, trim down the space. So I'll write the answer now. I will write the code for this. So at first let take n equals to nums dot length, length, and for applying a binary search we have to find the range. I'll take low is equals to 0 and high is equals to n minus 1. These are my ranges for applying the binary search, and we have to do the low is less than equals to high. So basically these are the conditions to apply the no, like, this is the range we have decided. This is the binary search basic condition. Now we have to let do the mid. What is the mid value? Math dot floor. We are finding the mid on the basis of an index value. We are finding the mid. So I'm repeating one more time. We are finding the mid on the basis of an index value. So we have done this. Okay, so here we have got the index value, and after getting that index value, I'll check, does this my index value is equals to my kth value? If it is yes, return high. Return. If it is yes, then return mid value, which is the my index. If it is not, then we have to do trimming down of space. Trimming down the space based on trimming down the space based on sorted half and number does exist over there. So I just have to write first condition in, like, first condition that, okay, what is the sorted half? If nums low is less than equals to nums mid. Over here I'm utilizing the values to find out the sorted half. So if nums low is less than equals to nums mid, this means left half is sorted. If the left half is sorted, then I have to find figured out left half is sorted, then I have to find in that particular sorted half, does my k value exist or not. And if nums low is less than equals to k and k is less than equals to nums high. Okay, if it is existed over there, then I have to trim down the right search space. Then I have to move the high equals to mid minus 1. If it does not exist over there, then have to trim down the left search space, low equals to mid plus 1. And same I have to do the for the right search space. Same condition over there also. If and else, just have to change this. If just have to change this for the right search space. Right search space. If mid no if nums mid is less than equals to k and k is less than equals to nums high. No, I on the here I figure out the left half is sorted. This is obvious, right? Else obviously the right half is sorted. I just have to check for the range. If nums mid is less than equals to k and nums mid is less than equals to k and k is less than equals to nums high, in that case right half is sorted and that range is valid. Right half is sorted and the range is right over here right half is sorted and range is valid. I have to check and range is valid. If that's the case, move it low equals to mid plus 1, high equals to also mid minus 1. Simple. Let's check it out. Okay, let's check it out. Then at the end, if you did not find anything, return minus 1. Let's check it. Okay, fine, let's try to submit it. Okay, I got the wrong answer where my output is minus 1 but they are expecting 0. Okay, I failed some test case. Let's check this test case. Over here I have num n equals to nums dot length low equals to 0, high equals to n minus 1. I have low is less than equals to high. I did this nums low is less than equals to mid. ठीक है. If nums low is less than equals to k and k is less than equals to nums high, I am on the left search space, then how it will be high? It must be a mid, and high equals to mid minus 1. Let's check it out. Let's try to submit it. Let's see. Accepted, right? So we have to be very careful while writing this. Over here I am in the left search space which is sorted. In that sorted search space from low to mid, I just have to find the k value exists or not high. I have to write the mid over here. Okay, now we have done the solution.